Welcome to Data Skeptic Time Series.
This is Data Skeptic Time Series, the podcast about how to predict the future based on historical sequential data. Episode number. If you didn't know much about supply chain before, you've probably learned a few things this year. When run extremely well and without incident, supply chains can fade into the background, kind of obfuscating the amount of information and forecasting and important work that goes into making that happen. Now, no one can predict unpredictable events, but after they've happened, decisions need to be made, and those decisions need to be based upon updated forecasts. It's a fascinating and important area where time series is applied, and in this episode, I interview Mahdi Abolghasemi about how these systems are deployed in practice and how to deliver the forecasts that power them.
My name is Mahdi Abolghasemi, and currently I'm a lecturer at Monash University, and I recently finished my postdoc in the Department of Data Science and AI at Monash University.
Well, congratulations on that. And tell me a little bit about your PhD thesis and the area you focus on for research.
Yeah, my PhD research was on forecasting in supply chain. Specifically, I was focused on forecasting demand during promotions and in the presence of volatility in supply chain. So promotional forecasting is investigated widely in supply chain forecasting by researchers and practitioners, but it's a still open research problem. There is no unique solution for forecasting during promotional periods. So during my PhD, I was looking at this promotion, and specifically I was interested to see this promotion. It makes the demand volatile, not just during promotion time, but of course, a few periods before and after promotion. And that volatility actually caused a lot of problems in the supply chain context for your inventory planning and of course for your demand forecasting, first of all. So my PhD focus was on understanding the demand volatility in supply chain and finding a way out to model this volatility in the supply chain context. My current research is, yes, I'm continuing to work on supply chain forecasting. I'm a little bit more focused recently on hierarchical forecasting. Specifically, hierarchical forecasting, it naturally sits down in the supply chain context. So recently, last few years, I've been focused on developing algorithms, specifically with machine learning algorithms to forecast hierarchical supply chains.
What happens if a large supply chain neglects the efforts of forecasting? What's the worst case scenario? How does it all go wrong?
Yeah, the forecasting is the basics of a lot of managerial decision in supply chain, whether it is transportation planning, production planning, inventory planning, everything. It starts with the forecasting demand. So if you neglect that, you will encounter a lot of problems. You're going to spend a lot of money probably for your inventory control, or if you have excess inventory, or you may run out of products and, a lot of customer satisfaction will be damaged over there. So that's just one aspect of it. But of course, it can cause a lot of problems in your transportation planning, in your production planning. You may not be able to commit to your plans. And so it is fundamental. It's the first step in every supply chain. You need to really forecast your demand and know about it in advance.
So promotions, at least if they're effective, they should have an impact on sales. We should see them in the data. What do they look like in the data?
Yes, we can understand the promotion in the data. Not always, but often it depends in the context as well. If you're looking at data sets and you can see large spikes, very, very large spikes, so you may say, okay, this might be a promotion, or that might be an outlier, you don't know. But often when we are looking at the data, if we know the promotion in advance, that we do have promotion in these days, if there is a spike that corresponds with a promotion date, so definitely that can tell us that that's a promotion. But it turns out that it's not often that easy to understand that promotion is there if you don't have the promotion date in your data. Sometimes, the uplift in sales is not as big. So you may think that, okay, it's just a natural volatility in your time series, in your sales, but it may be promotion. So if you have data about it, you know it, okay, this is promotion time, you can easily detect them. But if not, you really need to come up with your own solution to find out which one is promotion and which one isn't.
When a promotion period starts, it seems as though you've almost had a state phase transition. You're in a new mode. Previously, there was no promotion. Now there is one. Presumably, it will end. How do you look at it from a modeling perspective?
When we're looking at a modeling promotion, there are quite a lot of different ways to really model them. One very simple way that I've seen practitioners use and other researchers also have used is looking at simply price. We often know the promotion price in advance. We are the decision makers. We know when we want to put our products on promotion. If something is going to be on half a price, so yes, we know that is going to impact sales. So you can simply include that in a regression model to reflect the promotion. The other way that we can look at this is if you don't want to use the price as a regressor, you can use simply a dummy variable, for example, to reflect the promotion time. So that can help us to model promotion. There are many other ways that we can look at it, but just a couple of ways that we can incorporate the promotion impact, and they're widely used are probably regressors and also dummy variable.
So if we think of a metric like maybe it's daily sales or hourly sales with a large retail company, something like that, and if we looked at the data during a period of no promotion, so sort of a control group in a way, I still envision that there's a lot of volatility there. Volatility has many sources besides promotion. What does a typical data set look like in a control period?
Yes, we always have volatility up and down in time, so it's not a constant process. Yes, we can have a trend, upward trend or downward trends in our sales. We can have seasonality. We can have multiple seasonality that can make it even more challenging. And there are random variations in it as well. So they all contribute to demand, and we need to really look into them to be able to model them properly. There are techniques and ways that we can deal with each of them, but these are the main components of typical demand time series during non-promotional time.
And how do you go about measuring the volatility of the data?
Yes, volatility, there are different ways to measure that. One thing that I propose to use, simply using coefficient of variations. So what does that mean? Coefficient of variation is simply the standard deviation divided by mean of your time series. So that's a scale independent metric. If you have a large volume of sales or a small volume of sales, that doesn't impact it because we're dividing it by the mean. So that is a very simple way to look at the volatility of time series. But there are other techniques that other researchers have also used. But I propose to use this technique because it is really intuitive and easy to understand. And it has been shown that it can represent the volatility in time series, in sales time series context adequately.
And when you compare maybe periods of time with and without promotion, is it that there's more volatility during promotion, or is it just that the system is measurable in a variety of ways as being different?
That's a very interesting question. Actually, one common, I would say, mistake that some of the works that I have seen been done is that they may think that promotion is the only time that changes the demand and it makes our demand volatile. But it turns out that it's not just the promotion. There are periods before promotion and after promotion that are impacted by promotion, and actually demand volatility spreads out over at least a few periods of time. So yes, demand volatility is not only during promotion, but it is during post-promotional and pre-promotional periods as well. It may last even longer depending on the context that we are looking at, but in general, promotion definitely impacted. And the important thing that I want to mention again in here is that promotion itself also has different impacts. Some promotions have a smaller and some promotions have larger impact on demand and the demand volatility. So we need to take that into account as well.
I could imagine you being able to detect things about promotions sometimes in a spike event. If we think of something like a Super Bowl TV show, most people are watching the Super Bowl all at the same time. And if there's a great TV commercial, perhaps lots of people will visit a link or call a number. So it's plausible on Super Bowl Sunday, you could see a big spike like that. Apologies, I know that's an American reference, but a big sporting event that's quite popular. But that's sort of becoming more of an exception than the rule. We're less synchronized as a culture. We're watching things kind of on our own time. Does that make it harder for you to detect when the promotions show up?
So one thing is that we need to incorporate our knowledge about promotion into modeling. So for example, Super Bowl, we know exactly what day is happening, what time that's happening. So we can expect that there is going to be uplift in the demand. So that's the case for other promotional cases as well. If you have knowledge in advance, we have to incorporate that into our modeling. And it's not a problem. Like we have a lot of techniques that we can do that. But what happens is sometimes we have competitors in the market that may impact the demand. For example, in Super Bowl, okay, there might be another important competition that's happening at the same time, international level maybe. And so that may reduce the number of people that they're coming to watch Super Bowl. So we need to find a way out, okay, we may not have that biggest spike now because there is a competitor in here. So we need to put that into account. So these sort of things are important when we are looking at it. But modeling it is challenging, but there are techniques that we can tackle that definitely.
Yeah, could we explore further there from like a methodology point of view? What are some of the techniques you found to be successful?
For promotional planning, so techniques that are useful, different models that we can use and different information that we can incorporate, they can help us in modeling it. So of course, we have a lot of models. You can think of a Remax model, models that incorporate some regressors. You can think of dynamic linear regression. You can think of machine learning models such as support vector regression, neural net, and list goes on and on. So there are many different models, as I mentioned a few. But the other thing important is we need to also incorporate the information. What information really now impact? That's the important part. Okay, we know that looking at a specific problem, we want to incorporate information that we have. For example, if you think about sales, you want to incorporate price, but you want to incorporate if there is a holiday there or not. You want to incorporate if you're putting your product in a store, where you're putting that. Are you putting it in a special place or you're just putting it in one of the aisles? So different information like that are very important that we need to incorporate them into model. The other thing that is more difficult to incorporate is the competitors information. So that's something else that may counterfact the promotion sales for us. And that's also something that we can incorporate in the model.
Can you talk a little bit about the data set you were able to use in the research and in your exploration?
Yeah, sure. When I was doing my PhD, a company in New South Wales in Australia approached us and they were interested to improve their demand forecasting and reduce their inventory level. So we had communication, weekly meetings, and we gathered this data set, over 800 demand sales time series for different products. And most of them are impacted by promotion, but it's for different products and they have different promotion impact. You can see it has different seasonality, different types of trends. So it's a very interesting data set. It's coming from a real world time series and worked on these data sets for quite a few years. And it contains a lot of interesting features in it, which is in mimicking the real world for a lot of other supply chain probably as well. That's the data sets that I was working at.
What sort of features are available that are useful to the modeling?
Yeah, that's a very important question, actually. Feature engineering is one of the important things when we are looking at developing our model and algorithm. So typical things, of course, you can think of price, you can think of some dummy variables that you want to consider. For example, which day of the week we are at, which week of the month we are at. And some other features that is interesting is you can look at the average of, for example, average of sales during the last few days. You can look at the standard deviation of sales during the last few days or few weeks perhaps. So you want to look at that in a rolling window origin. So basically you want to look at that across your series. You can look at the minimum and maximum. That's something important as well. Like if you had a big sales, that's going to impact your sales now. You're going to probably have a smaller sales. Yeah, just some typical features that we can consider: mean, standard deviation, minimum, maximum, of course, price. Features like where it is sitting in the store, and also calendar features. They're important ones that we can incorporate in the modeling.
And I'm curious about the level at which you're doing the forecasting. Is it down to the individual product and SKU?
Yes, that was down to each SKU.
So broadly speaking, how many products is that? And do you have any challenges in the scalability of the work?
Well, the sample that I looked at, it wasn't as big. It was 800. But of course, when you're dealing with these and larger scales for big retailers, you're probably dealing with millions of them. And scaling is important. You need to come up with a method that works fast and accurate enough. Probably not too complicated as well when you're looking at in practice. Where practitioners want to work with models that they are more understandable and they're just good enough to work with.
And when you're picking a model, obviously there's the typical things we learned in textbooks: accuracy, F1 score, MAP-E, these sorts of things. Are there any other additional criteria that are important to you in the process?
Yeah, for the evaluation metric, it's important actually how we're going to evaluate. I know in a lot of industries, MAP-E is very common and popular because it's really easy to understand and easy to interpret, but it is not necessarily the best. There are some flaws into that, and academic researchers have looked at these metrics a lot, and practitioners, sometimes they have their own metric that they use that for evaluating a model. It's still ongoing, specifically in supply chain context. I think still we are lacking a proper metric there, because an accuracy metrics, if you think about it, maybe, okay, that doesn't translate, to inventory easily or to dollar cost for us easily. So these are the accuracy metrics for the demand. Okay, when we say 10% is a maybe, okay, we know that on average we have 10% error. But what does that mean in terms of our supply chain? 10% for a product that we sell of it 1,000 units is very different from 10% of the unit that we sell millions of it. So we need to come up with a better metric. Still, this is something that there is ongoing research for it, and there is a bit of disparity between researchers, which metric would be the best one there. But there are lots of other ones. You can think of MACE, mean absolute scale error, another metric that can be useful, but still ongoing research.
The following message comes from Data IQ, the platform for everyday AI. Let's face it, the potential for positive change with AI is huge. But seeing that value is hard. AI-driven growth is about organizational transformation, not just technology, and today's businesses struggle with the complexities of bringing AI innovation to fruition. That is where Data IQ comes in, infusing a culture of working with data and AI every day and at every level of the company. Whether solving for the mundane, like automating forecasting, or what is the optimal number of widgets to buy, or understanding moonshots that push the limits of today's technology to grow your organization and innovate. That's Everyday AI. Join more than 45,000 people worldwide across banking, insurance, pharmaceuticals, manufacturing, retail, and more who are driving results with Data IQ. Visit dataiq.com to learn more. That's dataiku.com. Thanks to this week's sponsor, Comet Backup. I've seen people learn hard lessons about backups. I once worked for this company. The CEO had this important presentation and a bunch of Excel files on his computer, and the hard drive went bad. It turned into this emergency situation. I was working around the clock writing SQL queries, and of course, those Excel files had all these pivot tables and stuff. It was crazy to recreate it. Hundreds of person-hours spent. There's nothing more heart-stopping than losing data. Whether you get hit with ransomware, hardware failure, or human error, data loss can be a business-ending event. Comet Backup is a fast, flexible backup platform for businesses and IT providers. It protects Windows, Linux, or Mac, and you have total control over your data. You can back up to local on-prem storage or any of the leading cloud providers. With Comet, you get secure encrypted backup software for computers, emails, databases, and servers. Best of all, Comet grows with your business with scalable per-device pricing. Test drive Comet Backup with a 30-day free trial and get $50 in free credit when you sign up with the promo code DATASKEPTIC. Start running backups in 15 minutes or less at cometbackup.com. That's cometbackup.com, promo code DATASKEPTIC. It seems to me that there's a lot of outside data that could be relevant. Holidays, or what day holidays fell on, are an interesting variable you could bring in. Maybe even something more abstract like the GDP could be somehow useful in your forecast. Did you spend a lot of time looking at outside data sources, or is it mainly just productive to work with the sales data?
100%, the outsiders are very important, and you need to incorporate them as much as you can. But the thing is, we don't have access to all of data. And some of data, their impact may be insignificant. You can gather a lot of information, put there like maybe hundreds of variables that they can impact your sales, but how many of them are really important and really significant? We don't want to make the model complicated without any purpose, but we want to have a good model that works well in practice with the accurate information that we have. As you mentioned, GDP, for example, yes, that you can incorporate that into model. And there are other information you can incorporate that into the modeling. In terms of weather, yes, you can incorporate them into the modeling. But some of them may not be as significant. So this really comes down to the model that we are looking at. We need to come up with the best features or subset of features that we want to consider.
As you mentioned, if we know the promotion's start and end date or properties about it, that can probably be built into the model. But you also seem to imply that that's not always available. I think for someone who has never worked in marketing, it might come as a surprise and sound like, the left hand doesn't know what the right hand is doing. How can it be that organizations don't have a very clear, exact, transactional log of when all their promotions happened?
Yes, I would say they often have, unless there is an error in your data gathering process. You may not know, 2 years ago, a year ago, what happened, you didn't have it. But then for the future, I think everybody should have it. If they don't have it, they need to think why they don't know and they communicate it properly. But yes, I would say that when you are going to model it in a marketing department, you definitely know, and you always have that information in advance for yourself. But what you may not have is the information for promotion for your competitors. That is this thing that you may not have it. But I would say for yourself, it should be okay. And once you have it, you can definitely incorporate that in the model.
Do you need to consider something about the quality of a promotion? It seems intuitive that 50% off is better than 10% off.
Yes, we might say 50%. Yes, it's better than 10%, and it is common sense, true. But sometimes promotions backfire. You have to look at the market as a whole. As I mentioned, the most important one probably is the competitors, what they are doing in the market. And of course, days are important as well. When are you going to put promotion? If you want to put something on sales for kids during the school holidays, that's not going to, if you put it on 50% sales, probably that's not going to boost your sales. And timing is definitely very important. It's not just about the price, and also competitors' information and other things. You need to consider them as a whole.
Well, I'd love to dig into some of the empirical results and the performance you looked at. I know you had the opportunity to explore a couple of different methodologies and options. Does there seem to be a clear winner? What techniques are really going to be good for doing this type of forecasting?
Yeah, for this one that I was looking at for these data sets, and there might be other data sets similar to this one, so this methodology can definitely work over there as well. So I came up with a hybrid model that is actually looking at promotional and baseline sales together. So what I did there in this research, I developed an algorithm actually that decomposes sales to promotional and non-promotional sales. And I use one model for non-promotional and one specific model for promotional. And then I combine them wherever it is appropriate to find out the total sales that we have. And it turns out that this model really works well for volatile time series. There are some other out-of-shelf standard models that they really work well for sales time series that they're not volatile or their volatility is really low. That means they're like more stable cells. So you can use more straightforward models. You can use a dynamic linear regression or a Remax model, and that works well. But when we're looking at really volatile time series, we need to come up with our own methodology. And the hybrid algorithm that I proposed, it turns out to work very well for very volatile time series. And it does a very good job as well for time series that they have low volatility.
In a case where there is high volatility, and let's say it's due to these variables we don't have the ability to observe, like the case of the competitors' promotions and rates and things like that, the algorithm can only do as good as it does, but if it's doing well, it sounds like it can be useful for an organization. Do you have any insight into how a company leverages that forecast, especially in a highly volatile environment? Who are the decision makers, and how do they look at the forecast and help use it to make those decisions?
Yes, the volatile time series, the output that we can get from that is very helpful in supply chain context. The volatility can cause a lot of problems in supply chain context. One of them is inventory costs. So companies tend to increase their inventory level to counter the impact of volatility, demand volatility. But that is not an effective solution because you're, causing a lot of cost for the supply chain. And some other supply chains, they have a strategy to increase their capacity to deal with the demand volatility that they might have. So if demand is going to go up, so they're going to, impose that into production planning, but they have a good capacity, so they won't feel it as much. But that is, again, it is not necessary. You don't want to impose additional costs to your supply chain. If you can come up with a good model that can tell you how the demand is going to change and what the demand is going to be, then you can use that more effectively to plan for your production planning and for your inventory. So that is very helpful for supply chain decision makers to understand how to deal with the demand volatility.
How far in the future are those people hoping to get forecasts that are accurate?
This depends on the context. In the supply chain context, again, different companies, different supply chains might have different horizons. But often we look at weekly and 4 weeks ahead and up to 8 weeks ahead. And also sometimes we look at longer ahead for, MRP or material resource planning. It depends on the context. But often for production planning, something between 4 to 8 weeks is totally enough. For other purposes, you might just want to look at, for transportation, you might just want to look at a week or 2 weeks ahead. So it totally depends on the context and decision makers, what is best for them.
And do you have any thoughts on how things like the pandemic have altered the approach people take? If nothing else, there's been, the big cargo ship that was stuck and a lot of events like this. I'm told the Port of Los Angeles, near where I live, is backed up to a historical record. It's never been this backed up. How do forecasters account for all of these unprecedented changes?
Yes, that's a very important question, especially at this time. The supply chain has disrupted really, really bad. We know that we have a lot of problems. We know all that. You go to last year, sometimes early in the pandemic, you might go to grocery store and you see that there is no toilet paper, or there are many other products that you're after. There is none of them there. That is indicative that the supply chain is in trouble and we need to come up with something better, with better solutions. So for pandemic, obviously, if you don't know it, if you haven't predicted that in advance, you haven't incorporated in the plan, so you're going to encounter problems. But now that we have experienced it, I think a lot of companies now are looking at risk management and looking at structural changes that they might have in their supply chain, coming up with solutions that what we can do if ever something similar happens. So there are, scenario planning that the different companies, you can do scenario planning that the different companies are actually implementing in that. But the most important thing is whether you can see it in advance or not. If you can't see it in advance, well, then you're in trouble. But if you can see it in advance, you need to really incorporate that in your supply chain planning.
And do you have any thoughts on the way an organization should structure its collaboration and things along these lines? I mean, maybe in the most advanced stage, somebody would develop an algorithm like the one you've developed, implement it in software, and the various managers could go in and get their reporting, and it could be totally self-service. But it strikes me that there needs to be more of a back and forth, that a person creating these forecasts needs to get some feedback from the organization. Maybe when you find some of those outliers, someone knows the secret as to why. What does a successful collaboration look like in rolling out solutions like this in large enterprise?
Yes, that's a very important thing, I would say, and I'm passionate about it. One thing I would say is collaboration really between enterprises and universities. That's crucial for success for companies and also for us in academia. That's very important. There are a lot of techniques that we have in academia and in universities that haven't been implemented in practice. And there are many techniques that practitioners they have developed in-house, but we are not aware of. They don't publicize that for, IP reasons or whatever reasons that they might have. And we never heard about them. And we don't know exactly what's the problem that they might have there. So collaboration, really having more conferences, having more conversations between these two communities are extremely important to implement the best practices. But when we look at the organizations on its own, they might have projects with other companies that is back and forth. It all comes down again to communication that they have. What's the problem that you have and how a person can really help to solve that problem. In my own work, in my experience, I've realized that one important thing is really identifying the problem. We have had quite a lot of, works with industry practitioners, quite a lot of meetings, and communicating the problem in a common language that both parties can really understand it. It's very important to be able to find the solutions. And then at the end, also agreeing on something that you can publish this work, you can publicize it. I understand there are some IP issues and things like that, but if we can come up with a solution that benefits all, that would be, I think, great, so we can share knowledge among the companies and people.
I believe your results show that the proposed hybrid model is really the right way to go, and it's going to combine the benefits of different models, like combining ARIMA and artificial neural networks. Do you have any insight into what each of those components brings to the table? Why couldn't one methodology alone have taken care of things?
Yes, in forecasting community, there are a lot of works have been done on combination and hybrid models. You might know that the famous M4 competitions was won by a hybrid model. So different models have different capabilities. They have a lot of things in common as well, but they have different capabilities. So the hybrid model that I proposed that was able to capture the promotional and non-promotional impacts together. Whereas if you want to go with a simple model, let's say with an ARIMA model, of course, that's not going to be able to capture the promotion impact properly. So hybrid model is a solution when we are looking at complicated phenomena that they impact our time series. And this is the algorithm that I came up for supply chain context for the demand time series that I was looking at. You might come up with some other models, not some other hybrid models for other contexts. So yeah, it comes down to the really problem that you're looking at. But in general, it has been shown that hybrid algorithms are really powerful for tackling complicated problems.
With many of the industrial time series applications I've learned about, I find that there's something they have to work on to scale. Maybe it's a case where they need to tinker with their algorithms, or maybe they need more data, or perhaps both in a lot of cases. If you were to continue working on this line of research, what are the directions you want to head in?
There is a lot that needs to be done in this area. So one thing that I still want to just mention is one thing is, of course, developing models for different promotional cases is important. As I mentioned, promotion is an open research problem. It's not just one size fits all. It's not like that, but you want to really come up with a solution for the problem that you have in hand. One important thing that I want to mention is looking at bullwhip effect. That's another thing in supply chain context, the volatility, how that's going to cause a bullwhip effect in your supply chain. We're looking at the downstream supply chain on the retailer's level, how that's going to impact your demand on distribution centers level or manufacturer level. That's another important thing, that this promotion impact and the volatility, how it moves in the supply chain. So there's a lot of other works that needs to really be done in this area, but just a couple of them that just comes to my mind.
And with those thoughts in mind, where do you see the bridge between academic research and industry? Are things moving in an efficient manner, or is there a lag?
We are moving towards it. I think there is a lot of work that needs to be done. As I mentioned, IP, I think, is one of the biggest issues that we have. We need to have more conferences that academics and practitioners, they go there and they talk to each other, they communicate. And with the problems that we have at universities, I don't know, in general, I'm just saying in Australia, probably other places, we are moving more towards industry collaborations, and we are interested to work on real world problems that really have impact. But this is not a one-way avenue, and I think it needs the collaboration from both sides. And from practitioners, I'm talking about from my side, but from practitioners' side as well, they have their things that they can do as well. I think there is still a long way to go. However, we have started this years and years ago, but I think we need more collaboration there.
Yeah, it's a tough problem and an exciting one to work on. So a lot of interesting things to be following up on for sure.
Yeah, and that's one of my passions, working on real world problems and really tackling the problems that we have in real world. But the problems are really, really complicated. It's not like you would say that I can do it on my own and I will find a solution for that. We really need to have multidisciplinary work. We need to collaborate, and I would say put our ego away and really collaborate to tackle the problems. We can see now, think about the supply chain that is disrupted in all over the world. So that is something that really needs the attention from both sides, academics and practitioners, to come up with a solution to solve these problems.
Well, to switch gears a little bit, I want to make sure I leave some time to ask you about the International Institute of Forecasters, and in particular, the Forecasting Impact podcast. What can you tell me about the Institute and the show?
Yes, the International Institute of Forecasters is professional community for forecasting people. We have people from academia and an industry. It's an amazing institute, and we have yearly conferences, International Symposium on Forecasting. And it's really interesting. We have people from different backgrounds. We have people from economy, tourism, energy, supply chain, deep learning. We have people from different backgrounds coming to this conference. And the Forecasting Impact, actually, that's the initiative that I'm running with a group of early career researchers. So in Forecasting Impact, We are passionate about publicizing the forecasting practice, best practices in forecasting. We have people coming from, academia and also industry to our podcast, sharing their knowledge and expertise. And we are passionate about, publicizing the forecasting principles and practice, really. Yeah, we will be happy if you have any feedback to let us know. And we'll be happy to have guests if someone is interested to come to our podcast.
Where can listeners go to find out more online?
Yeah, you can go to Forecasting Impact Buzzsprout. So the Forecasting Impact Buzzsprout is Forecasting Impact, and then .buzzsprout, BUZZSPROUT.com. So you can find us over there. And you can also find us on the International Institute of Forecasters websites.
Well, we'll have links to those in the show notes. How about yourself? Where can people follow up on you and your research?
Yes, you can find me on Twitter. I have my LinkedIn account, my Google Scholar. You can find me over there as well. So my Twitter is Mahdi Abolghasemi, is MAHDI-ABOLQASEMI. So that's my Twitter, and you can find me also on LinkedIn and on Google Scholar as well.
Yeah, Mahdi, thanks so much for taking the time to come on and share your work and expertise.
Thank you for the opportunity.
That concludes another installment of Data Skeptic Time Series. Our guest today, Mahdi Abolghasemi. Thanks to our sponsors, Data IQ and Comet Backup. Myself, Claudia Armbruster, as Associate Producer, Vanessa Bly, Guest Coordinator, and our host, Kyle Polich.